Welcome to Study Loop.
This is the answer to Chapter 22, problem number 47 from the Smith Organic Chemistry textbook. This problem asks us to draw the product formed when phenylacetic acid is treated with each reagent. And we're told that with some reagents, no reaction occurs. And there are 12 of these, so I'm just going to go ahead and get started because this is going to take a little bit of time. Okay, so for A, we have sodium bicarbonate. That's going to act as a base, and we have a carboxylic acid that we're starting with. Oh, and I drew phenylacetic acid at the top of the screen here. Rather than redraw the aromatic ring 12 times, I'm just going to use a pH to abbreviate it, since the ring itself is not participating in any of these reactions. Okay, so sodium bicarb here is going to act as a base, and so we're going to get an acid-base reaction, and we'll deprotonate our carboxylic acid, and we'll get the sodium ion as the counter ion here. Okay, so that's A. For B, again, B is a base, and so the exact same thing is going to happen as in A. We will deprotonate, and we'll have the sodium ion as our counter ion. Okay. C, we're using thionyl chloride. Remember, thionyl chloride takes a carboxylic acid to the acid chloride. And so we'll have an acid chloride for our product there in C. D is just salt, table salt. There's going to be no reaction here. Okay, so then E, and actually, let me move these up a little bit. Okay, so in E, we're using one equivalent of ammonia, and so that is going to just act as a base. And so, again, we're going to get deprotonation and no further reaction. So deprotonation, and then we'll have the ammonium ion as the counter ion. Okay, for F, we're using ammonia followed by heat. And so that is actually going to drive this reaction. And so rather than just deprotonation here, we're actually going to make the amide. Okay, so there we go. There's F. Moving on to the next page here. For G, we're using methanol and then sulfuric acid. And so we're going to get the ester product here. And so since we're using methanol, we'll get the methyl ester. For H, we're going to try to do the same thing, but instead of using acid, we're going to use base. And so that's not going to work. And so we will end up just deprotonating. Okay. For I, we're using sodium hydroxide followed by an acid chloride. And so this is going to create the mixed anhydride. So we deprotonate, and then our deprotonated oxygen is able to act as a nucleophile and kick out the chlorine in the acid chloride that we're using as the second reagent in this sequence. And so we end up making the mixed anhydride. So then for J, we're using methylamine and DCC. And remember, DCC is going to act as a dehydrating agent here. And so that is going to allow us to form the amide. And since we're using methylamine, our product is going to be methyl amide. Okay, for K, we're going to use thionyl chloride, and then we're going to use propylamide. And so the thionyl chloride is going to make the acid chloride, and then the propyl chloride is going to add to that. And so we end up with the amide. So 1, 2, 3. Okay, and so L is going to be similar, but we're not using an amine, so we're not going to get an amide. we're using an alcohol, and so we'll get an ester. And so the ester will be the propyl ester. Okay, so there we go. Yeah, so that's all of the products to these reactions. And that's the answer to chapter 22, problem number 47.